In this video, I'm going to talk about the intermediate value theorem. The first version of the intermediate value theorem says that let f be a continuous function defined on the interval ab. Suppose that f of a times f of b is less than 0. That means f of a and f of b have opposite sign. Then there exists some c in the open interval ab such that f of c is equal to 0. It also means that the equation f of x equals 0 has a solution in the open interval ab. In the first graph here, f of a is less than 0 and f of b is greater than 0. And this is the graph of a continuous function on the interval ab. By the intermediate value theorem, there exists some c in the open interval ab such that f of c is equal to 0. In this situation, there exists a unique c in the open interval ab such that f of c is equal to 0, or the equation f of x equals 0 has a unique solution in the open interval ab. In the second graph here, f of a is greater than 0 and f of b is less than 0. And again, by the intermediate value theorem, the equation f of x equals 0 has a solution in the interval ab. And in fact, in this situation, this equation has three distinct solutions in the open interval ab. This is a very important theorem of calculus, and it is very useful for proving that a certain equation has solution on a given interval ab. Now let me use more figures to illustrate the intermediate value theorem. In the first figure here, this is the graph of a continuous function on the interval ab. So you can draw the graph of the function without lifting your pen up. And therefore, this curve must meet the x-axis at some point in the interval ab. And at that point, at that number c, f of c is equal to 0, or c is a solution of the equation f of x equals 0. In the second figure here, this is also a graph of a function on the interval ab. However, this function is not continuous on this interval. And from here, you can see that the equation f of x equals 0 doesn't have any solution on the interval ab. The reason is that this function is not continuous on the interval ab, so you cannot apply the intermediate value theorem. In the third figure here, we can draw this curve without lifting your pen up, but this curve doesn't meet the x-axis at any point in the interval ab. However, this doesn't violate the intermediate value theorem either. The reason is that this is not a graph of a function because it violates the vertical line test. If you draw a vertical line going through this point, then this vertical line meets this curve at two different points, and therefore this is not a graph of a function.